Thank you. We are a little bit ahead of schedule, so that's nice. And I also want to keep it short because I gave an introduction yesterday on what we try to aim for in work package 6. So I basically want to go directly into the content. I want to give a small recap of what I showed you yesterday. And I also noticed something went wrong with the animation, so that's why I clicked very fast. What we have been talking about, what this whole workshop is about that we have a need for prioritization. We took the results from yesterday, compounds that are classified already as PM, and as I said before, we want to bring in the T today. We had a lot of discussion yesterday about the criteria for PNM, the uncertainties, etc., but we're not going into that now. But once we have a compound being classified as being PM, we want to prioritize them also further to see if we need better data on the P and the M side, but also particularly on the T side, what we discussed today, or if we know already sufficient about these compounds, that we can just say, yes, these are really compounds also of toxic concern, so that we should consider them as being regulated. That is the need that we aim for in our work package. And so the goal is that we come to this risk-based prioritization framework, taking for granted that these compounds have been qualified as P and M. And we take into account then, because we work from a risk-based approach, we take into account both the toxicological hazard and the exposure. We restrict ourselves, getting back to the previous question, to the human exposure based on drinking water, and we consider this as part of the tiered approach. We perform within ZeroPM no animal testing, so we base ourselves on NAM-based approach, but we have, of course, selected data-rich compounds, so we know quite a lot of in vivo results from these compounds. And our ultimate goal is to come to this risk matrix based on the risk 21 program. So, I go. Yes. So I showed you this triangle yesterday, and I just want to highlight today that we are in this tier 1, where we do our practical work. So what we do basically, we run in vitro bioassays, and they will be further. They give us a threshold value, which we can then translate by in vivo to internal benchmark concentration. Of course, this also helps in hypothesis building for higher tiers. So we will come up with suggestions for higher tiers maybe in the end. And on the exposure side, we come up with predicted environmental concentrations through multimedia, fate models, and again then we will consider these concentrations as drinking water concentration, a kind of worst case scenario, and translate that back to internal concentration in the human being. And we also use existing monitoring data that are out there. So this is our ultimate goal, to come to an internal exposure in a human being and to have a human equivalent benchmark concentration, which we consider as a toxic hazard, and then we put them on the axis and try to fill this risk matrix. And you see the numbers here, which refer to the different presentations that we will have today. So we will go, we take the list of the 3 classes of phase 1 compounds that we have, triazines, triazoles, and PFAS, and how we actually selected these individual compounds. We tested 36 compounds altogether, but we will show you later how we selected these. We try to come to emission data and then develop precocity-based fate models. That's the first presentation that we will have now. After my talk, then we come to an external exposure concentration, and we model that into an internal exposure concentration. That's what Abhishek will deal with in the third presentation. On the other hand, we screen these compounds for their hazard. In the bioassay battery, we come to an in vitro benchmark concentration, and again, the same modelers, so that we combine these presentations, use the in vivo modeling to come to the human equivalent benchmark concentration. And then we compare these and try to construct this risk matrix and classify these compounds as a red, an orange, or a green. So the program of today, we've heard the very nice presentation by the keynote speaker, who was from the Commission or JSC, but now we enter the ZeroPM program. We start going on the curiosity-based models, multimedia activity model from teaching environmental research. Then we have a presentation by Maxime Collier from Vrije Universitet Amsterdam on the hazard profiling of these compounds. And then we will have the presentation by Abhishek about the modeling, so the PDK modeling and the in vivo modeling. Then we have a coffee break, and then Sylvia Escher will present the results of our risk matrix, where we integrate everything all together. I didn't put your logo there, Sylvia, because it's a combined effort of all three groups involved in this work package. And now we will have a discussion for free before the lunch. And I hope you enjoy the program. And I want to invite Todd to kick off. Thank you.
ZeroPM, Zero Pollution of Persistent and Mobile Substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 101036756.